Hey everyone, Ronak this side. I hope you all are doing well. So let's get into the problem of the day. So what the problem states here is, okay, so first understand what a rotated sorted array means. So I mean you have given an array nums. Let's consider it's 1, 2, 3, 4, 8. So it's a basically sorted array in ascending order. And now what do you mean by rotated sorted array? Rotated sorted array, you have to cut one portion from anywhere and just replace this, I mean, push it in backward and take the back one and push it in front of that nums. So basically, what nums become if we rotate it from here, 1, 2, 3, and 8, 4 comes first. Okay, so now it's become rotated sort of starting from here and ending from X. I mean, it's gonna become 4 and 8. So if take another example, let nums equal to 1, 2, 3, 4, and 5. And now let's consider we have to rotate it one time. So for rotating it one time, what we're gonna do, we just gonna pick the last element and put it in first, like 5, 1, 2, 3, and 4. And if you want to rotate it one more time, and just put the last element and put it in the first, 4, 5, 1, 2, 3. Yeah, simple as that. So what question is asking here? Given the rotated sorted array nums of unique element, every element is unique, it doesn't have any repetition here, return the minimum element of this. So what will the brute force you can come, I mean, you just have to return the minimum from there. So just iterate over a array one time and just store the answer equal to, I mean, answer equal to minimum of answer comma nums I mean, I is the just I is the index we are iterating over that complete array. So if you want to code this, just let's give it a try. So let's first consider an integer in of size of the array, and just iterate over the array to 0, I less than and I plus plus, and initialize a variable answer. Consider it int max for now. Now what the simplest line of code we're gonna write here is answer equal to minimum of answer and nums of index I. Nums of, so it's basically gonna iterate over the complete array and pick the smallest one and just return the answer. So let's see if it's working. Okay, so we got perfectly fine code. Let's submit this and see if it's, yeah, we got 0 millisecond time complex, 0 millisecond. But can you optimize it further? So if you whenever the questions contains the sorted part, you just have to click the binary search. I mean, somehow if you can implement binary search, we can reduce the time complexity from big O of n to big O of log n, big O of log n. So let's try to do this. So first thing we have to notice here is, so let's, okay, so take an example, just consider 5, 1, 2, 3, 4. And what binary search basically means, just start from low and go to high. On based on sub condition, just push low to this, I mean mid plus one, or push high to this. So that just cut the array to half and keep cutting half. That's reduce the time complexity of log and if you know. So one thing to notice here is, if first consider low as here, okay, and high as here, what will the mid become this? So one thing to notice, so first we have to identify the sorted part. So which one is the sorted part? If we compare, if so what we're gonna do here is first consider low and high and the government. So first we have to identify the shortest part. The one part is always sorted. I mean, if here we got two parts, this part is sorted and this isn't. So how do we gonna identify the which part is sorted? So there's a special condition. If low is less than equal to mid, why we put equal to here? Because it can have 2, 1, and low is pointing here, high is pointing here, mid is pointing here, so it can be equals. Okay, so if low is less than equal to mid, so if low is less than mid, what we gonna know that left part is sorted. Left part is sorted. Okay. And if, I mean else, if I is greater than equal to mid, then right part is sorted. Okay. So what if we check condition here is low is less than equal to mid and low is greater than equal to mid. So left part isn't sorted, right part is sorted. So what we're gonna do here is we just pick up the smallest element from the sorted, I mean sorted part. So what will the smallest element sorted part? It's 2. Okay. So let's just store answer as 2. And again, we after picking this, we pick the smallest element from the sorted part, and delete the sorted part. So I mean, we gonna move the high to mid minus 1. So just move high to here. And now what does mid become? Mid become this. So is mid is less than equal to low? Yes. So we consider left part it's sorted. Okay. Left part is sorted. So pick the minimum from left part. It's 5 and move the and delete it. I mean, move the low to here. So it's become low, and now this is only remaining. Now we got answer equal to 5. So what we're gonna do is answer equal to minimum of answer, and what is this, I mean minimum of sorted array. Minimum of sorted part we gonna take minimum of both. So here we minimum we get is 5. So 5 is not less than 2, so we not gonna change the answer. So now mid become 1, low become 1, high become 1. So is low is less than equal to mid? Yeah, low and mid is both is 1. So left part is sorted, I mean this part is sorted, the only part. So what is the smallest element in this sorted part? Of course 1. So we're gonna compare answer 2 comma 1 and minimum, and we got a minimum of 2 and 1 is 1. So now answer is 1. So let's try that it in another example. So first let's write the clean code of it. While low is less than equal to high, mid equal to high plus low by 2, and if left part is sorted, I mean low is less than equal to mid, what we're gonna do is just take the answer minimum of answer. And okay, so if this left part is sorted, okay, left part is in sorted order 1 comma 2 comma 3. So what will be the minimum in the sorted? Of course the low. So what we're gonna do is we just gonna nums of low and delete this part. So we're gonna move low to mid plus 1. Okay, if this is mid and this is the sorted part, we're gonna pick the lowest, I mean lowest min low, and move the low index to mid plus 1, and low equal to mid plus 1. Okay, and if we can put the else statement to here, because if left isn't sorted, right of course gonna be sorted. Else answer equal to minimum of answer comma, and if right part is sorted, I mean low, high, low, mid, high, and left part is sorted, right part is sorted 1 2 3. What will the minimum in the right sorted part? Of course the mid one. So nums of mid, and now picking the after picking the smallest element, let delete this part, I mean move high to the mid minus 1, high equal to mid minus 1. And just after just simply writing this while loop, just we have to return the answer. So let's see if this code's gonna work or not. Okay, now let's submit the code and see if it's working fine or not. Okay, we again got the 0 millisecond time. I mean, oh, fine. So now let's analyze the time complexity of the code. So if we see the previous code we have written, I mean simply iterating over the whole array, what will the time complexity? The time complexity there will be big O, and but after doing this, what will the time complexity? It's become big of log, and if you know the binary search always give a logarithmic time complexity of the total size of array. So and space complexity here we are using is 0. We are not, I mean constant. We are not using any extra space. That's it for today. If you like the video, please leave a like and make sure to subscribe to Tenza and turn on the notification bell for more such interesting content. And feel free to ask doubt in comments. I'll try to reply every possible comments. See you tomorrow. Till then, keep grinding.